In this video, I'm going to teach you about different types of numbers that are used in calculations. So let's get to it. In mathematics, there are two types of numbers: rational and irrational numbers. Let's start with the rational numbers. A rational number is any number that can be written as a fraction. So, in other words, they're written as a over b, where a and b are both whole numbers and b is non-zero. Examples of rational numbers include 1 over 2, 1 and 2 over 5, or negative 3 on 4. Types of rational numbers are fractions, integers, percentages, terminating decimals, recurring decimals, and ratios. So, let's start with fractions. A fraction is just any number that represents a part of a whole. Fractions are written with a numerator over a denominator. So in other words, a numerator is the top part of the fraction, and the denominator is the bottom part of the fraction. For example, 1 over 2 has a numerator of 1 and a denominator of 2. Examples of fractions include 5 on 6, negative 2 on 7, and 4 with 1 on 3. Now let's move on to integers. An integer is any whole number. So, examples of integers would include 1, 8, negative 5, 0, or 12. Now, you might be thinking, why are integers considered rational? They're whole numbers. How could they be considered as rational numbers? Well, integers are rational because they can be written as a fraction with a denominator of 1. For example, 5 can be written as 5 over 1. Now let's move on to percentages. A percentage is any number between 0 and 100 used to represent a part of a whole, and it's written with a percentage symbol. Examples of percentages include 5%, 13%, and 81%. Again, you might be asking, why are percentages considered rational? Well, percentages are rational because they can be written as a fraction with a denominator of 100. For example, 9% can be written as 9 over 100. Now let's move on to terminating decimals. A terminating decimal is any decimal number that ends. So in other words, it's any decimal number that has a limited number of digits and decimal places. Examples of terminating decimals would include 3.2, negative 0.4, negative 7.25, and 0.0249. Once again, one would ask, how could they be considered rational numbers? Well, terminating decimals are rational because they can be written as a fraction by multiplying by 100 over 100 and simplifying. For example, 0.5 is equal to 0.5 multiplied by 100 over 100, which is equal to 50 over 100, which can then be simplified to 1 over 2. Now let's move on to recurring decimals. A recurring decimal is any decimal number that has a digit or a group of digits that repeats forever as a pattern. Recurring decimals are denoted with a dot on top of the repeated number. So, for example, 0.1 with a dot on top of the 1 is equal to 0.1 reoccurring. 0.4 with a dot on top of the 4 is equal to 0.4 reoccurring. And 0.27 with dots on top of the 2 and the 7 is equal to 0.27 reoccurring. Reoccurring decimals are rational because they can actually be converted to fractions. So for example, 0.2 reoccurring is actually equal to 2 over 9. Now let's move on to ratios. A ratio is simply any comparison between two values, written with a colon symbol. Examples of ratios include 8 to 5, 3 to 2, and 7 to 9. Ratios are rational because they can be written as a fraction by simply replacing the colon with a fraction symbol. So, for example, 1 to 4 is equal to 1 over 4. Now that we've discussed all types of rational numbers, let's move on to irrational numbers. Unlike a rational number, an irrational number is any number that cannot be written as a fraction. So, in other words, irrational numbers are non-terminating decimals. That is, they have an unlimited number of random digits and numbers that follow after the decimal point. Examples of irrational numbers include root 3, because as you can see, root 3 is equal to a whole set of random digits and numbers that go on forever after the decimal point. Another example of an irrational number is pi, which again results in a whole set of digits and numbers that follow on forever after the decimal point. I hope that everyone has learned from this video. If you have learned from this video, please leave a like. And if you want to see more videos like this, please subscribe to my channel. Thank you for watching.